The question we are solving now belongs to test series 3. It is of signals and systems subject. In specific, it belongs to LTI systems and jet transforms. The question is numbered 48. It's a common data question. As per the question, there is a cascade connection of two LTI systems, S1 and S2. The S1 system is causal and the LCCE DE means linear constant coefficient difference equation representing the system 1 is given as W of n is equal to half Wn minus 1 plus x of n. Here x of n is input, W of n is intermediate output means output of system 1 and y of n is the final output. The system S2 is also causal and the LCCDE representing the system is given as y of n is equal to alpha times y of n minus 1 plus beta times delta of n. The complete cascaded system is represented by the LCCDE y of n is equal to minus 1 by 8 y of n minus 2 plus 3 by 4 y of n minus 1 plus x of n. We have to find the values of alpha and beta. We know that for the system S1, the system function can be obtained by taking the jet transform on both sides. Thus, W of z is equal to half z inverse W of z because the jet transform of W of n minus 1 is equal to z inverse of W of z plus x of z. So upon simplifying this, W of z divided by x of z is equal to 1 by 1 minus half z inverse. So this is further equal to h1 of z. So this is the system function of system 1 and ROC of the system is modulus z greater than half. This is because the system is causal. Similarly, the system S2 for the system S2, the system function can be obtained as y of z is equal to alpha z inverse y of z plus beta w of z. Upon simplification, y of z by w of z is equal to beta divided by 1 by 1 minus alpha z inverse. This is equal to h2 of z means the system function of the system 2 and the ROC of the system. This system is given as modulus z greater than modulus alpha. So based on these two, the overall system function is given as h of z equal to h1 of z multiplied by h2 of z, which can be written as beta divided by 1 by 1 minus half z inverse multiplied by 1 minus alpha z inverse. And this ROC of the cascaded system is given as modulus z greater than max of modulus alpha, comma half. Now we know that here h of z is equal to y of z by x of z. Now the LCCDE can be obtained by taking the inverse Z transform on both sides. So this becomes 1 minus alpha plus 1 by 2 Z inverse plus alpha by 2 Z power minus 2 multiplied by y of Z is equal to beta times x of Z, which can be further simplified as after taking the inverse Z transform, y of n is equal to alpha plus half y of n minus 1 minus alpha by 2 y of n minus 2 is equal to beta times x of z. Upon comparing the equation 1, which is marked here, and this is also the LCCDE given, with the equation 2, we can see that alpha plus 1 by 2 should be equal to 3 by 4 and beta should be equal to 1. So upon simplifying these two equations, we can see that alpha should be 1 by 4 and beta should be 1. So the correct option would be